Hello, everyone. So, I am Miss Mansfield, and thank you so much for watching this video. I will help you through this lesson, which is translations and reflections review. And then, kind of halfway through the lesson, we are going to start a new topic, which is rotations. I know it's the first day we're going to actually talk about it, but don't worry, we're going to go like one step at a time, and everything is going to make sense. All right, so here we go. First things first, let's do a warm up, right? I recommend that you open Desmos for this one and also grab your notebooks. If you don't have your notebook with you for whatever reason, please pick a piece of paper so you can follow along in this class, okay? And then you either put that paper in your binder, your folder, or you copy the information later in your notebook. So here we go. For our warm up for today, we have this one here that says the table shows the number of gallons of gasoline in a car's gas tank after the car has been driven for X miles. And then we have the table. Then the question, when these data are graphed on a coordinate grid, the points all lie on the same line. What are the slope and y-intercept of this line? So I'm looking for two things, right? I am looking for the slope and the y-intercept, okay? So here we go. Please open Desmos, like I said before. Click on plus and create that table, right? So Desmos first, and then you click on plus, and then you click on table, right? And then Desmos should create an automatic table for you that says x1, and then it's divide, and then on the other side y1, and then you get to put your points. Please remember, you don't have to put all these points, right? Only 2 points is enough for Desmos to do its job, okay? So you can pick 0 and 15, and then 10 and 14.6, or any other 2 points should work as well. After that, we should write our equation. Well, actually, we should write our formula, right? That actually generates. If it says all points lie on the same line, it means it's just like y equals mx plus b. But we are in Desmos. So y1, and then we put the tilde, the squiggly line, mx1 plus b, right? Because that needs to refer back to the table that Desmos created for us right before. All right, perfect. When you press enter or after that, you should have your M and your B, right? You should have something like M equals and then B equals. So please remember, M is the slope and B is the y-intercept. If you look at the B, your B is 15, which helps you a lot because you can already cancel 2 options over there, right? We can already cancel letter F because B is 15, and we can already cancel age because B is 15. I know it's either G or J, right? Now, because your M is a negative and it's a decimal, you should already know it's G. But if you don't, it's okay. Don't feel bad. On the line underneath it, which I believe it should be 3 because we have table on 1, formula on 2. So then on line number 3 in Desmos, go ahead and copy that decimal, right? Just as a review of how we change decimals into fractions. Okay, so copy that decimal. I believe you have 0. Negative, right? 0.04. As soon as you do that, right in front of it, you should see like this symbol over here, something like this. It's like a round shape with like a square on top, a line, and a square on the bottom, right? You should see that pop up, okay? This is actually a button. If you click on that, it changes your decimal into a fraction. All right, and then you just see -1/25, which makes G our answer, right? Just a very good warm up for us today. And now we are ready to continue on our lesson over here. So let's review first translation, and then we are going to review reflection. Okay. Review number 1 on your notebook or your piece of paper, please write review 1. So then you know which slide we were talking about. Okay. If your teacher wants to review that later. And then here we go. It says triangle Q on a coordinate plane was translated. Ooh, very important word over here, right? It was translated. Please write that on your paper so you don't have to copy the whole entire sentence or the whole entire question. Just the keywords should be enough. Translated 2 units to the right 2 units right, and then 8 units up. Awesome, very good. So this is what your paper should look like, something like review 1, right? And then you should, because so I know which slide that we are talking about, the keyword translated. And then how was it translated? 2 to the right, and then 8 up. You see what I mean? This is what your paper should look like, something like that. Okay. Of course, if you want to make the title like stand out, underline, or write it a little bigger, however you want to organize it, but make it organized, please. Okay, so anyway, so 2 units right, 8 units up to create triangle Q prime. Which rule describes this transformation? I want you to change these words into a math formula, into numbers and letters and symbols. Okay? Well, if we are moving right or left, that means I'm talking about the x, right? So if you think of a graph, whenever we draw a graph like this and we have our x's, right? This is our x-axis over here, and this is our y-axis over here. So if I'm moving right or left, that's the x. So that's why we start over here with open parentheses, x, right? Because that's what I'm talking about. Now, whenever I move right, that means positive, right? The more you move right, then your numbers will increase. So that's positive. So x plus, how much are you moving to the right? In this problem, you are moving 2 units to the right. So x plus 2. Sounds good? Now let's try the y. Hopefully this is like ringing some bells and bringing your memories back. Okay, now every time that I move up or down, it means I'm talking about the y. Look at our y-axis over here, right? It's the line that it's the ruler that moves us up and down. So if it's up, then y up is positive, right? Every time we go up, our numbers go higher. So it means y plus, and how much am I going up? I'm going 8 units up. That's it. A, B, C, or D. Which one looks exactly like that? I believe our answer for this one is letter D, right? Letter D looks exactly like that. What I always ask my students to do, and what I really recommend that you start doing as well, is to check why are the other ones wrong. So you create that analysis of why can't I pick A or B or C in this case. This is really good for your brain. Your brain gets like really strong, really smart when you're able to detect the mistakes on the other ones, right? So look at letter C. Let's work our way up since we know D is correct. Letter C gave me a -2, like x minus 2. That's not okay, right? If I'm going to the right, that should be positive. So that's why it cannot be C. This negative over here is not okay, right? So not letter C. What's wrong with B? Well, B, even though it matched the right letter with the right numbers, they are flip-flopped, right? The Y is coming first and then the X. When we are talking about translation, this never happens. The X goes first, the Y goes second, just like any other coordinates, okay? So it cannot be B because of that. It switched the positions over here, right? Letter A. Well, the X is first, the Y is second. Beautiful, perfect. But now they switch the numbers, right? Now they have X plus 8. It's not supposed to be X plus 8. It's X plus 2. The 8 goes with the Y. Okay, so A is wrong because they switched the numbers, the positions of the numbers. Sounds good? Are you ready for review number 2? So here we go. Let me clear that, and then we're going to go to review 2. Pentagon T, and they start with this word pentagon to scare you and see if you're easily scared by big words that maybe you don't remember exactly what they mean. Don't be scared. Just as a reminder, a pentagon is a shape with 5 sides. All right? But don't worry about that. You're going to see that's actually not important in this problem. Let's keep reading. Pentagon T on a coordinate plane was translated. Ooh, important keyword over here for us. Translated 7 units down and 4 units left. Again, guys, on your paper, please do me a favor, write review 2, put the title, the keywords translated, 7 down, 4 left. Okay, put that on your notebook. At any point, if you need to pause this video, pause, write on your paper, write on your notebook, and then you press play again. It's that simple. Okay, it's going to help you follow at your own speed. So here we go. But anyway, it was moved to create pentagon T prime. Which rule describes this transformation? Okay, so here we go. Let's try. If it says it was translated 7 units down, the one that moves up and down, that's our Y. It started talking about the Y. It's actually trying to get you again, not only with the word pentagon, but about talking about the Y first. Guys, in translation, the Y always goes second. Okay, so this is going to be the second part of it. I'm actually going to write it over here like a little lower, like 7 down, right? I'm going to write that second, and then 4 left. Left and right, that's my X. That's the one who needs to go first. So I'm going to write it up here, 4 left. Okay, I'm always going to try to organize my notes and my papers like that, to mention about right and left first, right on top, and then up and down second. So I know X and Y, so I know the order that they go. Okay. All right, so here we go. So let's start writing our mathematical way. So I have X. Left is negative. Every time that on the coordinate plane we move to the left, the numbers get smaller. So we are losing quantity, we're losing amount, right? So left is going to be minus negative. How much am I going left? 4. So X minus 4. Now let's talk about the Y. Even though the problem mentioned it first, we know in translation the Y is always going to go second. All right, so Y. Now it's going 7 units down. Whenever we go down on a coordinate plane, our numbers get smaller, right? So it has to be negative. So Y minus or negative. How much am I going down? 7. There we go. That's my answer. Which one looks like that? Which one is my best option? Letter A, right? I think it's actually the very first one there. Letter A. Let me see. What is wrong with B? B switch the numbers. The 7 is coming first and then the 4 is coming second. That's not okay. That's a trick that the problem is trying to play on you, right? Let me see letter C. I have X plus 4 and and plus 7. We cannot have positives over here, right? If we're going left and down, they're both supposed to be negative, not positive. Let's see letter D. I have X minus 4. Beautiful. It started off on like perfectly. And then I have Y plus 7. I cannot have a plus 7 over here. That's not okay. If I'm going down, it's supposed to be negative. Does that make sense? Any questions? If you have questions, pause the video, write your question down, and then ask a teacher whenever you have a chance. You can always stop by my room and say, Miss, I have a question about this. I got confused on this problem. I am always here for you. Sounds good? So here we go. Let's keep going. Review 3. Again, on your paper, go ahead and please write the title, Review number 3. And let me see this one here. Point A is located at 8, 2 on a graph. Ooh, this is a very interesting one. I like this problem. What is the location of A prime under the translation XY translates into X plus 7, Y minus 2? All right, guys, it's like we have a machine. We're going to put the ingredients in this machine. This machine is going to transform our numbers. My question is, what is coming out of this machine, right? What is it doing to those ingredients, to those numbers that I'm putting in? What is happening inside the machine that pops out like a different outcome, right? So that is what I want to know. So here we go. This is what I wanted to understand. My 8, 2. Do you agree that this 8, let me change the color over here, maybe to a red or something like that. Do you agree that this 8 is my X? And this 2, oh, a little lower here. And this 2 is my Y. Up until here, is that okay with you guys? I think that's okay, right? The X first and the Y second. Well, this is the transformation that I'm applying to it. This is the translation that I'm applying to it. Whatever X I have to add 7 to that. Whatever Y I have to take away, I have to subtract 2 from that, right? Okay, so I have my X is 8. So I'm supposed to do 8 plus 7, right? This is the transformation that it's happening over here. Let me go back to my blue. I don't know if it's, there we go. So I'm supposed to do 8 plus 7, right? That is the transformation that it's happening inside my machine. I'm adding 7 to my X. Now let's see what's happening to my y. Y minus 2. My y is 2, so 2 minus 2. You see what I mean? I'm plugging in those numbers in place of the x and the y. I'm substituting the numbers. All right, what are those results? 8 plus 7, and you guys can use decimals. You can count on your fingers. You can count on your head. You can tap on your desk. I don't mind whatever way you use. Just get there, and it's totally fine. Okay, let's just get there. So 8 plus 7, 15. So I'll open over here. Where's my, there we go. 15. And then 2 minus 2, 0. Which letter says that? Letter C, right? That's my letter C over here. That's my answer. Okay. On your paper, I don't want a random letter C floating over there. Okay. Again, I want the title Review 3. I want the point that I gave you originally, 8, 2, and I wanted to write on the bottom the 8 is the x and 2 is the y. I want the 8 plus 7 and then the 2 minus 2. I want the 15, 0, and then the letter C. All right, I want the whole thing there to help you understand what is going on when you revisit that paper. Otherwise, what does a random letter C on your paper mean for you? Right? That's going to be weird to review. Awesome, guys. So here we go. Review number 4. Now that I believe you guys are doing fantastic with translation and sliding, right? Remember, translation is actually the whenever we slide a shape. Okay, let's talk about a different one. Let's talk about reflection. So here we go. On your paper, please write review 4. And this problem reads, quadrilateral ABCD is reflected. Ooh, keyword, please write that on your paper. Across the x-axis, very important information that it's reflected on the x-axis. Please write x-axis on your paper. To create quadrilateral A prime, B prime, C prime, D prime. Which rule describes this transformation? All right, so let's think about reflection. Okay, if you have your chart, let me show you over here what your paper chart should look like. Something like this. Take this out of so you can see the whole paper. If you have a paper that looks like that, right, over here with all the 4 parts and all your formula, go ahead and grab that paper. That's really going to help you. But if you don't, let's think about reflection. Well, every time we reflect over the x-axis, remember x-axis is horizontal. It means the shape is on top or from the bottom up, right? But it's reflecting like this. The x doesn't change because the mirror, it's on the x-axis. If the mirror is on the x doesn't change. The y will change. And we'll talk about this change in just a second. If the mirror is on the y, if it's a vertical mirror, right, and it goes from here to there, the y is going to stay the same. The y is not going to change. Only the x will. Mirror on the x stays the same. Mirror on the y stays the same. All right, so let's check that out. Let's see what that means in like math and symbols and all that. So we have over here quadrilateral. It's reflected on the x-axis. So if I have x and y, that is going to change into, well, x has to stay the same, so x stays there, but the y changes. What I mean by change is the sign changes. Okay, not the number, not the letter, only the sign changes. So if it's positive, it's going to turn into negative. If it's negative, it's going to turn into positive. So here I had a positive y, so it's going to become a negative y. The sign is going to change. Which one says that? A, B, C, or D? Let me see. X first, Y. That's a letter A, right? That's my letter A. Right over here. Y, letter A says that X stays the same and Y changes sign. Did that make sense? Did that kind of came back reflection for you as well? Let's try another one about reflection. Let's see how we do on the next one. Review 5. Go ahead on your paper. Review 5. This one says, a circle is graphed on a coordinate plane and then reflected, keyword over here, extremely important, across the x-axis. If the center of the original circle was located at xy, which order pair represents the center of the new circle after the transformation? Okay, we're talking about reflection, x-axis. If it's on the x-axis, the x stays the same. So I'm looking for something that keeps my x exactly the way that it is and it doesn't change it. That means my y has to change and only the sign changes. So negative y. This is what I'm looking for. Letter, not A, not B, letter C. I believe that's letter C. Letter C. Did that make sense? Mirror on the x stays the same. Mirror on the y stays the same. All right? Great, guys. Fantastic. Last one here about reflection. Triangle HJK is graphed on the coordinate grid. Oh, I'm sorry. This one here is review 6. Please put that on your paper. You don't need to copy all those pictures, okay? Don't worry about that. So here we go. Triangle HJK is graphed on the coordinate grid. Triangle HJK will be transformed using the rule, so please copy the rule. This is going to be important, right? This is the transformation that it's happening from xy to negative xy to create the triangle H prime, J prime, K prime. So here is the original, this over here is the original image, right? It's what we call pre-image. And I want to know which one then, A, B, C, or D, is actually going to be this transformation. Which one is the correct H prime, J prime, K prime? All right. Well, so let's think about it. Look at the rule that I gave you, xy, negative x, y. Do you see the y stayed the same? Do you see the y didn't change? Right? Well, if the y didn't change, it's because the mirror is on the y. Remember that? Mirror on the x stays the same. Mirror on the y stays the same. That's what happened over here. The y stayed the same. So my mirror has to be on the y. My reflection is on the y axis, which means the shape is going like this. Guys, clearly it cannot be B. I can already throw B away because B is reflecting down. That would happen if my mirror was on the x-axis, but that's not. Look at the x changing. From x, it went to a negative x, correct? So it cannot be letter B because letter B, the mirror would be on the x-axis. So that's not okay. Not letter B. Letter B can go. Letter B is wrong. All right. Letter D, my triangle is kind of rotated, but it's like on the same spot. It didn't move to the other side, right? So it cannot be letter D as well. Like where did you go? Where did you move? What happened? That's not what we're talking about. Correct? Letter C. I think letter C, it like flipped the shape like twice or something like that because it went to the other side and down as well. Like that's too much. Okay, it's only supposed to go to the other side. The mirror's on the Y. So from left to right, right to left, and so on, right? So it has to be letter A. Letter C is not right either. Our answer, letter A. Guys, on your paper, review 6, this transformation rule, xy, the arrow, negative x, y, and then letter A. Okay, that should be good. If you want to sketch the triangles, if you want to sketch the graph, don't worry about being perfect. Don't waste your time in class doing that, but you can do like a quick figure, a quick drawing about that, and then move on to the next one. Okay, and remember, you can always pause this video. If you think I'm talking too fast, you can always slow down the speed of the video, right? Make me talk slower over there. All right, and then that's it. So pause anytime that you need. Let's try the next one. Quick write. So here I'm going to give you a few minutes to try this one. I'll give you an example, but I would like you to pause this video later on and try your own, okay? So the question here is, describe in your own words real world objects that require rotation to operate. We are done reviewing. We are starting rotation. We are starting our new topic for today, okay? Rotation, guys, it's the same as like turning. Okay, so it's anything that goes like this or the other way, of course, like this. This is rotation. All right, so here we go. Let me give you one example, and then again, I would like you to pause this video later after my example and try a few on your own. In real life object that rotates, clock. Clock rotates, right? Or the clock gear, or if you want to be more specific about what about the clock rotates. Okay, so right now, please pause this video and make a list on your paper or your notebook about other real life objects that also rotate. Go ahead, pause the video. All right, I hope you had something on your list. So here we go. Some other objects that I saw my students writing today in class. Some of them wrote tire. Beautiful, the tire of a car, a truck, a bicycle, right? Tires rotate. Fantastic. I love when they said that. Balls, right? A football or a soccer ball or whatever other, they rotate as well. They turn. What about a wheel? Maybe like a steering wheel of a car, right? But wheels, they also rotate. Okay. So there are so many things. Like, what about the planets? The Earth rotates, right? It spins around. So you can say planets, or you can say, I don't know, Earth if you want to be more specific, or something like that. All right. But anything along those lines, guys, that's awesome. That's really good. Okay. Those were the objects that I wanted you to think about whenever we say rotation. Okay. We're going around. That's the most important thing to remember. So here we go. Rotation overview. There are two very important things we need to know about rotation. First of all, the direction. There are two directions and only two directions that things can rotate. Okay. One of them we call clockwise. That means the direction of the clock. The clock only goes in one direction. Okay. Which is this one here. This is always the direction that the pointers of the clock go. So every time we rotate something this way, we call it clockwise. That means the direction that the clock goes. Okay. The other way, it's called counterclockwise. Counter means against. Okay. So it means against the direction of the clock, like opposite to the direction of the clock. So every time something is moving this way, right, the other direction, it's moving counterclockwise. It's moving against the direction of the clock, the other way that the clock goes. All right. So those are the two directions we're going to use. Now, those are very long words, right? And we like to abbreviate some words. So here's how we're going to abbreviate. Clockwise, we're going to say CW. Counterclockwise, CCW. So clockwise, counterclockwise. I hope that made sense. So let's see what else is important about rotations. How much are we going to turn? You guys already understood that we can turn this way or we can turn this way. Great. Now, how much are we going to turn? Are we going to turn just a little bit or are we going to turn a lot? Okay. Good news. This year, we only need to worry about four different numbers, four different degrees of how much we're rotating our shapes. Okay. They are 90 degrees, 180, 270, and 360. And they're all over here listed for you. You can list that on your notebook as well. Those are the only four numbers we need to worry about when we talk about rotations. If you look at this picture over here, it's like, oh my gosh, there are so many numbers, so many degrees. I'm going to go crazy. Don't go crazy, okay? We are only talking about, let me circle them for you over here. We're only talking about 90, 180, 270, and 360. It's actually when we go back to the beginning. All right. So here's the thing. Let me give you an example. Okay. So I'm over here facing you, right? Facing the computer. So if I rotate, if I turn 90 degrees, I'm going to stop here. This is where I'm going to stay. This is 90 degrees. If you have a circle and you separate your circle into four parts, right? Look over here, this example. Instead of separating into all these parts, I can only separate into four parts. 90 degrees, it's like moving like one slice, one part. And then again, if you imagine that you're only cutting into four slices, four parts, okay? But if I start here, 90 degrees, it's when I move this way. Does that make sense? 90 degrees. Let's talk about 180. If I start over here and I move 180, I'm going to move two slices or two parts. I'm going to move 90 plus 90, 180. I am facing exactly the opposite way of when I started. I started over here and I finished over here, right? All right, that's 180. Let's talk about 270. You're going to move 3 parts of this 4 slices. Okay, so here we go. I'm starting over here, looking at you, and then 90, 180, 270. I'm looking this way now. You see what I mean? All right, and the last one, I bet you can imagine what is the last one. 360. It's all the way around. So if I'm rotating 360, I'm rotating all 4 parts. 360 is the whole entire circle. I am going all the way around. So if I rotate, so if I'm starting here and I rotate 360, I go whoa, 360. And I always finish where I started. Okay? So if I'm rotating 360, I end up exactly on the same place. All right, guys. So we know rotation, direction, like which way are we rotating, right? Clockwise or counterclockwise. And then how much are we rotating, how many degrees? Whew, a lot of information. I know. Now, here's the thing. Usually, our tests and quizzes and STAR tests, they will not put a lot of numbers in those questions, okay? They will pretty much ask about the rule. They will see if you guys understand well where your picture will end up and if you can represent that in coordinate points. Now, take a deep breath. It sounds like a lot. It sounds like kind of crazy, like, oh my gosh, what am I going to do? Okay, so we have this chart to help you memorize these rules. Okay, so here's the chart and here's what we can do. There's a way to help you memorize. There's a chart that we can use to help you memorize these rules. All right, we are going to review them a lot, so eventually, hopefully, you will naturally memorize these rules. All right, so here we go. It goes like this. The teacher walked in the room and she said X, 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 X. The students say why, 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 right? Because it's weird if the teacher walks in the room and the teacher just says X, 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 X. The students will go, why, why? Okay, so hopefully you will remember that. So X, 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 taking turns like zigzag. The students respond why on those empty spaces. Now, for the signs, we're always going to skip the first one and we're going to go right, left, right, left. Miss, what do you mean? I mean like this. You're going to put negatives on the right, left, right, left. You see what I did? Right? So from the beginning, the teacher walks in the room and she says X, 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 X. The students ask why? Skip the first one. Right, left, right, left. That's where you're going to put your negative signs. Okay. Now let's make this look a little prettier. Let's make this look like math. Okay. So we are going to put a parenthesis over here, right? And we are going to put a comma in between, and we are going to put a parenthesis at the end. We're going to do the same thing with all of them. I know they're all crooked, and I will fix those for us in just a second. But parentheses, comma, parentheses, parentheses, and comma, and parentheses. Again, guys, I know this looks ugly, but I will fix it in just a second. Parentheses, comma, parentheses. You see what I did? Let me make this look a lot prettier here for us. Ta-da! All nice and pretty, right? Hopefully your paper looks like that. If it doesn't, because the last one was like very confusing, it's okay. Pause the video and now make it look pretty. All right, but here we go. Let me remind you how I got those coordinate pairs in the way that I did. The teacher walks in the room and says X, 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 X. The students reply, why? Skip the first one. Right, left, left. And then we make it look like math. Then we make it look pretty. All right. Next part, I like to put a line on top over here to separate the title from the information. On this side over here, I am going to put the clockwise directions, right? And on this side over here, I'm going to put the counterclockwise directions. All right. Now I'm going to start with the counterclockwise. I think it's easier to remember how the numbers go if I start on this right side with the counterclockwise. We are going to go from the highest number that we remember there are only four. We're going to start with the highest one and go all the way down to the smallest one. Okay. So the first number here we have to remember is 360. After that, we have 270. After that, we have 180. And the last one, 90. All right. On the other side, we are going to have 360 and 180 exactly on the same position. So 360 is going to go first over here. 360 is going to go first, and then 180 it's going to be exactly on the same line over here on the same place. 180, those two do not change places. Okay, it doesn't matter which side they are. Okay, clockwise or counterclockwise. Now the other two will flip-flop. The 90 that was last, now it's up here, and the 270 that was over there in second place, now it's in last place over here. I know it sounds like, oh my gosh, it's a lot of information. It's a huge table. How on earth am I going to memorize that? Don't worry, take a deep breath. We are going to write this table like a lot of times, and we have 4 months to memorize this table. The STAR test is all the way in May, right? So, again, one more time, how did I write this table? The teacher walks in the room and says X, 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 X. The students reply Y, 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 Y. Skip the first one. Right, left, right, left. Those are your negative signs. Put the title on top. Clockwise, counterclockwise. Counterclockwise, 360, 270, 180, 90. Right? From the biggest number to the smallest number. Now, clockwise, 360 and 180, they stay in the same position. 360 is the first one. 180 is there like in third place, right? Exactly on the same line. 90 and 270 will flip-flop. The other two will flip-flop. 90 goes higher up in second place, and 270 goes in the last spot. Is that okay? I think that you guys can do it. I think that you guys are doing fantastic. Let me show you how these can be asked and will probably be asked not only in class quizzes but also on the STAR test. So here we go. Look at the next one here. Look at your chart to answer those questions. When you rotate 90 degrees clockwise, what is your rule? So look at your chart. Look for clockwise. Look at the side that has clockwise. Okay, I'm not going to put it on the screen. You have to look on your paper now. Okay? And then if you didn't copy the table, if you didn't have time, go back on this video, pause it, and make sure you have that on your notebook or your paper. All right? Look at clockwise. So then look back on your paper clockwise. Look for 90 degrees, 90 degrees, 90 degrees. What is that rule? What is that formula? This is what I'm asking for. Right? Hopefully you guys can see why negative x. Hopefully that was your answer for this one. Can you see that there? Is that okay? Did that make sense? Yes? If it did, let's keep going. If it did not, pause the video, put a question mark close to this one, like I don't get it, don't understand, I'm confused, and then come talk to your teacher or come talk to me or to any other math teacher. All right? We can always help you. All right. Let's try another one. Number 2. When you rotate 270 degrees clockwise, guys, now I'm talking about 270 degrees clockwise. Look at your chart. Look at your chart. You don't need to memorize. You memorize the chart. You don't need to memorize the individual ones, right? Okay, 2 clockwise. Yes, clockwise. I'm looking at my chart. Clockwise, 270. Over here, I have, let's see if we have the same thing. I have negative y, positive x. Oh, it's not this symbol. Is that what you have? Do you have the negative y, the positive x? That's what I have. Hopefully we have the same thing. Sounds good? All right, let's try one more. When you rotate 180 degrees, if the 180 doesn't move on our chart, if it stays on the same place, it's because it doesn't matter if it's clockwise or counterclockwise, right? Just like I did with the chair. Do you agree that if I rotate this way, 180 degrees, I'll stop over here? Right? What if I turn the other way, right? I'm over here facing you, but now I want to turn this way, 180 degrees. That's the same thing. I ended up looking at the same place, right? That's why 180 and 360, it doesn't really matter which way you're going. So here we go. What do you have for 180 degrees? What is the rule? What is the rule? What is the rule? Hopefully you have negative x, negative y. Hopefully you have that negative x, negative y on your chart, and you can find that. And you can understand your chart and how your chart works. One more, one last one of those. Here we go. When you rotate 90 degrees, okay, 90 again, but now we are going counterclockwise. 90 degrees counterclockwise. Look at your chart. Counterclockwise, CCW, 90. What do you have? What do you have? Hopefully you have negative y, positive x. Hopefully that's what you have. Hopefully you know how to find that on your chart. All right. Let's see how these problems are asked on a STAR test, right? How is the STAR test going to test me on that? Or class quizzes or anything else that we have to answer, okay? What will you be expected to do? That should be your question. So here we go. This is an actual STAR test question, I believe, from 2 years ago. So just so you understand how you will be asked to answer about rotation. So here we go. This problem says, oh, on your paper, by the way, please write we do number one, so I remember which picture we were talking about, okay? You don't need to copy the picture. If you want to sketch it, you can. That's fine. But here we go. As long as you write we do number one, I believe it should be good. But this one says the coordinate grid shows parallelogram PQRS, and then there's the picture. There's the parallelogram, right? Nice and pretty. Parallelogram PQRS is keyword rotated 90 degrees clockwise about the origin to create parallelogram P prime, Q prime, R prime, S prime. Which rule describes this transformation? Look at your chart, right? Here's what we're going to do. Remember your formula chart with all your formulas that we do annotations like Y1, squiggly line, AMX1 plus B, and then we write the formula for the volume of the cylinder. We write that capital P stands for perimeter, and we have to add, you know what paper I'm talking about? Hopefully you do, right? On the back of that paper, there's nothing there. It's blank. That's where you are going to draw your charts. We're going to get there, okay? Not today, but we're going to get there another day. But on the back of this formula chart, you can write the transformations formulas, right? So hopefully on the day of your test, you're going to get your formula chart. You're going to brain dump all the annotations. You're going to turn it back. You're going to brain dump all the annotations for transformations as well. And you're going to have your chart with you. So then I'm going to use my chart because I know that on the day I will do that. So I will not, you will not be given the chart. You will have to remember the chart on your own, right? But we can do it. So here we go. Rotation 90 degrees clockwise. On my chart, I'm looking at my chart. Hopefully you are too on your paper. Clockwise, 90 degrees. Mine says y negative x. So from x to y, right? Because it's the normal one. It changes into y negative x. Y negative x, I believe that's letter J. All the way down here. Is that okay? You see what they're going to ask? It's just the formula. And if you have your chart memorized, we are good to go. Let's try another one here. On your paper, please write, we do number two. Look at this one here. True start question two. Look at the symbol there for the start. Quadrilateral ABCD is rotated, keyword, write that on your paper, 90 degrees clockwise. All right, to transform a quadrilateral. Which statement is true? There will be 3 lies and 1 truth over there. I'm looking for that truth. Letter A, the sum of the angle measurements of quadrilateral ABCD is 90 degrees less than the sum of the angles. First of all, whenever we rotate or translate or dilate or something like that, the measures of the angles will never change, right? Even if the picture grows or shrinks, the angles always stays the same. All right. So if the angles are not changing, if the angles never change, let alone in rotation, guys, in rotation, it's not getting bigger or smaller. It's just turning. Nothing is getting bigger or smaller. The size is not changing of anything, right? So, okay. So here we go. If the size is not, I cannot pick A because A is saying that the sizes are changing over here. I don't even care if it's angles or sides. Nothing is changing. Okay. It's just the position. Let's see B. Quadrilateral ABCD is not congruent Congruent means equal, so not equal. Yes, it is. It's equal. It has the same size. It's just kind of like upside down or sideways. But it's equal. It's the same size. It's the same thing, right? I cannot say that it's not congruent. Yes, it is. So this B is out. Let me see. The perimeter of quadrilateral ABCD is less than, not less than, not at all, right? Again, the size of the walls of my shape are not changing. They're just flipping. They're just rotating. So it cannot be C. Let me see D. Hopefully D is right, and I have at least one right. The side lengths of quadrilateral ABCD are equal to the corresponding side lengths of quadrilateral A prime, B prime, C prime, D prime. Yes, they are equal. I love this word equal, right? So D is our correct answer. All this reading to look for the word equal. Oh, for crying out loud. Here we go. Let's try. We do number 3. We do number 3. Please write that on your paper. This one says trapezoid PQRS is rotated, important keyword, 180 degrees about the origin to form trapezoid P prime, Q prime, R prime, S prime. Which statement is true? All right, here we go. 3 lies and 1 truth. I'm looking for that one. Rotated 180. The direction doesn't matter because it always ends up in the same place. The sum of the angle measurements of the trapezoid is 180 less. Oh my gosh, we've talked about that. Nothing less, nothing more. For crying out loud, F is already wrong. I'm not even going to finish reading. G, trapezoid PQRS is not congruent. I think this is pretty much the same as we do number 2. It's just changing from a quadrilateral there, whatever, to this trapezoid over here, right? But not congruent? It is congruent. Okay, it is congruent. H, the area of trapezoid PQRS is less than the area of the trapezoid. Is the trapezoid growing or shrinking? No, we are just rotating, right? So if I have, for example, I have an eraser over here, a kitty eraser, right? If I rotate my eraser and now it's upside down, is this a bigger eraser? No. Is this a smaller eraser? No. So the area doesn't change. It's exactly the same. H is wrong. Hopefully J is right. The angle measures of trapezoid PQRS are equal. Yes. To the corresponding angle measures equal. Yes. To the corresponding angle measures of trapezoid P prime, Q prime, R prime, S prime. Yes, letter J. I recommend that on your paper you write. We do number 3. Rotated 180 degrees equal J. Those are the keywords that we are looking for. Okay, write the word equal. Extremely important that you understand that the shape is equal, the shape is the same. Here we go. We do number 4. Yes, we do number 4. A figure is graphed. We do number 4 over here on your paper. We do number 4 on your notebook. A figure is graphed on a coordinate grid as shown. The figure is rotated, keyword, rotated 90 degrees counterclockwise. You can abbreviate. Remember CCW, counterclockwise, as the center of rotation to create a new figure, which rule describes. Okay, get your chart, look at your chart, eyes on your paper with your chart or your notebook, counterclockwise, 90 degrees over here. I see on my chart negative YX, which means letter C. Hopefully you see the same thing. Yes? No? Do you understand a little better how to read your chart? Yes, hopefully you are shaking your head as at your computer when you watch this video. Here we go. Next one. I believe the next one is a you do. Yes, this is a you do. So I'm not going to solve this one. I believe you can do this one on your own. I'm not even going to tell you the final answer. Okay? So go ahead, pause, read the question, find your keywords, find your key number, find the direction, how much you're moving, and look at your chart, and then you give that one a try. All right. And then after that, we have a DOL. It's only one question. Please go answer your DOL. It will be posted for you as well. All right. Thank you so much for watching. I hope you made it to the end, and I hope this made some more sense. All righty, guys. Bye. Take care.